because now we know kind of our big three rules for differentiation: product rule, quotient rule, and chain rule, and we're going to try to kind of combine them with each other. So we're going to see, how could we get them to work together? And this is where it is going to get a little bit trickier. And so, I might end up splitting this up with some homework problems and just focus on them one at a time. But I want to at least try, because we are going to have fall break coming up. I want to try to push through this. So, basically, we want to just really be thinking product rule is going to happen anytime we see an x next to another x without a plus or a minus. Quotient rule is pretty obvious when it happens. You get a fraction bar. And chain rule is less obvious, but it's really anytime you see like a square root of something, a sine of something, or maybe something like squared, when that something in there is not just x, it's something more complicated than x. So in this case here I see 5x next to x without a parentheses. That's probably product rule. But then I also see the square root of something, that's chain rule. So we're going to see both of those rules. Okay? And the more practice you get, the more you're going to start to learn what to do first. But essentially kind of think of it as the opposite of PEMDAS, right? PEMDAS, I would have focused on the x plus 3 first. But the opposite of PEMDAS, we're going to focus on the outside first. We're really always going the outside first. So on the outside, we have 5x times square root of x plus 3. That's product rule. We're going to do product rule first here. So f prime of x equals, now the derivative of the 5x part is 5. Product rule says that we leave the other part alone. So times the just square root of x plus 3. Then plus, now product rule says now we leave 5x alone, and we do the derivative of the second part. Now, the derivative of the second part, square root of x plus 3, right? What did we say for square root of x? We said that the derivative will be 1 over 2 square root of x. So instead of, if we have box, square root of box will be 1 of 2 square root of box times the derivative of the box. So I'm going to use that shortcut. So this is 1 over 2 square root of the box, x plus 3, times, now it's just times 1 because the derivative of x plus 3 is 1. So this gives us 5 square root of x plus 3 plus, now a lot of times what you'll see happen is that when you have a fraction, you're going to move the numerators up, the terms being multiplied up to the numerator. So 5x over 2 square root of x plus 3. And this is a totally perfect answer. I would leave this as my answer. Some multiple choice questions, you will see them go ahead and simplify this. So they might say 5 square root of x plus 3 over 1 plus 5x over 2 square root of x plus 3. And so you can multiply this side by 2 square root of x plus 3 and 2 square root of x plus 3. I'm not going to really worry about that, but just remember that when you do this, what's going to happen is the 2 and the 5 are going to multiply to get 10. Square root of x plus 3 times square root of x plus 3 is going to be x plus 3. But what I see a lot of people do is they write times x plus 3. That's wrong. You need to put it in a parentheses. And then plus, 5x. So I'm not going to finish this one, but just kind of showing you guys, you could keep going, right? The 10x plus the 5x, I think you end up with 15x. I guess I will just keep going. Plus 30 over 2 squared x plus 3. So, this could be the answer as well. But again, most of the time, just leave it. Don't really worry about combining the denominators. So now, next one. Obviously, we have a quotient rule. That's easy. We have a quotient rule because there's a fraction. But we have that sine of something. So just, kind of remembering, okay, if we have sine of box, then our derivative is cosine of box times the derivative of the box. That's chain rule. And which one should we do first? Well, we always go outside first. So we always start off with our outside. So our outside here is the sine part. So when we do the sine part, what's the derivative of sine? Is cosine. I'm going to write in cosine 2x plus 1 over x minus 3. And then I crossed out my cosine. Now I'm going to multiply by the derivative of the box, right? This is our box. Now when we do the derivative of that box, what's going to happen is we're going to have to do quotient rule. So now, it's not just a 2x there, it's this whole big thing. So we're going to have to do quotient rule. So times low d high minus high d low all over low squared. And honestly, on free response, you can literally leave your answer like that. Now, if it was a multiple choice question, you're probably going to have to simplify a little bit more. But on free response, you don't have to really simplify at all, which is nice. So this will be times, now distribute the 2, 2x minus 6 minus 2x minus 1 all over x minus 3 squared. The 2x's cancel out. Negative 6x minus 1 is negative 7. And usually we put the trig term in the back. So I'm going to say negative 7 over x minus 3 squared. That was from this part. I'm going to put that to the front times cosine of 2x plus 1 over x minus 3. Right? We usually put the trig term at the end. You don't have to, but it's just kind of practice. So there's that. Another one. Now this one's a little bit weird, and this one's hard to see the outside, and so I've had a lot of students kind of mess up on this one. But if I had squared, the outside would be squared. In the previous example, we had a sign around our fraction bar. The outside was the fraction bar. But in this example, the outside's actually the fraction bar. And if you're not sure what the outside is, just kind of think, if I was going to plug in a number, like if I was going to plug in 2, square root of 2 times 2 plus 5 divided by 2 minus 3, what would I do first? Would I do the radical first, or would I divide first? Right? And the answer is we would do the radical first. So that's actually what comes last, right? And that's because we said we're going backwards with these. We're starting with the outside. We're doing kind of the reverse of PEMDAS. So in this case, we're going to do the quotient rule first. That's going to be our first thing we do. So we see this, and that's just practice. The more you do at these, you're going to start to realize like what steps to go in. They're difficult, okay? So our first step is going to be to do quotient rule. So low, x minus 3, d high. Now this is where we have to do the chain rule. D high, the derivative of a square root, we've done a few of these now, is 1 over 2 square root of that box, 2x plus 5. Now times the derivative of the box is just 2. Then minus high, d low. The derivative of the bottom is 1. All over low squared. So this now becomes, and it's going to be a little tricky, but it's definitely doable, x minus 3 times, now our 2's can cancel out, so times 1 over square root of 2x plus 5 minus square root of 2x plus 5, all divided by x minus 3 squared. Now this is almost perfect, but you don't ever want to have a fraction inside of a fraction. So this term here is kind of messing with us because we have that fraction inside of the fraction. So we want to multiply by its denominator. So we're going to multiply by square root of 2x plus 5. And I know we're not used to this, so this is where I really need you guys to pay attention closely and really think about this and try to really commit this to memory. Is when you multiply by the denominator, you have to multiply to each term. Now, this is all going to get grouped as one term. Why? Because it's being multiplied together. This is going to be a second one term, and this is going to be the third term. So if we notice, basically the minus, or if it was a plus, but that symbol there is acting kind of as our separator. So what we're going to do is we're going to multiply times square root of 2x plus 5 times square root of 2x plus 5 and times square root of 2x plus 5. We multiply it to each term. Now, on this first one over here on the left, right on this guy, where do we multiply it to? Do we multiply it here? Do we multiply it here? Do we multiply it here? Or everywhere? Okay, and the choice is you actually multiply it to either one of the parentheses. I can multiply it to this parentheses on the left, in which case I would have to distribute. Or, instead of doing that, I don't do that, and I only multiply it to this parentheses. And since we're trying to cancel out the fraction, that's the one we're going to do. But you don't multiply it to both, you do either one. So I'm going to multiply it there, and the parentheses, like basically the radicals cancel. So this gives us x minus 3, we're going to leave that parentheses. Oh wait, no, this whole thing canceled, right? Because that was the point. The whole thing canceled. So the whole thing canceled, and we just are ending up with 1. Right? The reason the whole thing cancels is this is in the numerator, that's in the denominator. Now here, this is what I was getting ahead of myself on. On this, they're both in the numerator, but the square root of 2x plus 5 times the square root of 2x plus 5 is essentially the square root of 2x plus 5 squared, so those do cancel. Now, be very careful on this one. A lot of students will write this, and they get this question wrong. If you write it like this, minus 2x plus 5, you just got it wrong. Because what happens is, this minus is subtracting the entire thing. So it's minus, right? When these cancel, you can cancel them, but you need to put it in a parentheses. Okay, parentheses are very, very important in math to make sure that your signs are correct. Then the denominator, we're just going to leave it as x minus 3 squared times the square root of 2x plus 5. Nothing cancels. So now if you want to distribute this negative sign, you can. Right, so I'm going to go ahead and do that. Make this plus, make that minus 2x minus 5. So those are like terms, and negative 3 and negative 5 are like terms. So we end up with negative x minus 8 divided by x minus 3 squared times the square root of 2x plus 5. And this is a perfect answer, full credit. Every now and then, a multiple choice question might just factor out that negative. A lot of times they don't like to have an x term, like the highest x term, have a negative next to it, so they'll factor out a negative. So, basically, either one of those two would work. But for me, I just stop there. Okay, so now let's look at it with a graph. Okay, so if we're looking at it with a graph, we have p of x equals the square root of h of x. Okay, this is something we've practiced the last few days, and that's whenever we're doing these questions, we always don't look at the graph yet, don't look at the table yet. First, take the derivative, and the kind of key is if we had h of x, the derivative of h of x is h prime of x. So that's our key. So this does say find the equation of the tangent line, so I'm going to kind of write that off on the side. x1, y1, and m. My x1 is negative 4. For my y1, we're going to do p of negative 4. So p of negative 4 is going to be the square root of h of negative 4. So this is composition. We're putting the negative 4 in where we see the x. So now p of negative 4 is going to be the square root of, now h of negative 4, that's the y value. So h of negative 4, that's going to be our y value here. And that's going to be the square root of 4. So we get 2. Now for m, do not think it's the slope, right? Because, yeah, the slope is down 1 over 2, down 1 over 2. But we're doing this for p of x. We're not doing it for h of x. This is the graph of h of x, right? That's why my y value here isn't 4. It was the square root of 4. So what we have to do first is, before we can find m, we first have to find p prime of x. That's really important. So we're going to do the derivative. So when we look at this, what do we see outside? The outside is the square root. So I'm going to do 1 over 2 square root of, now we leave h of x alone, and times the derivative of what was inside. The derivative of that box is times h prime of x. Okay, so now we're going to do p prime of 4, negative 4, and that's 1 over 2 square root of h of negative 4 times h prime of negative 4. Now, this is where we're going to have to use the graph and realize the difference between h of x and h prime of x, right? So h of x is the y value. So the y value we already said was 4. H prime of x is going to be the slope. So the slope here is down 1 over 2, down 1 over 2, down 1 over 2. So it's going to be negative 1/2. So this will be negative 1 over 4 square root of 4. And if you want to, honestly, what can be a little bit, oh, I messed that up. Square root of 4 is just 2, huh? I'm dumb. So the square root of 4 is 2, and 2 times 4 is 8, so it's negative 1/8. So we'll have y minus 2 equals negative 1/8 times x plus 4 when we do x minus negative 4. Okay. And lastly, we'll move on and we'll look at these with tables. So same deal. What a lot of you guys started doing was like trying to look at the table too fast. Don't try to look at the table too fast. Kind of ignore it, like get rid of it until we've taken the derivative. So we have h of x equals f of g of x, right? We always start with the outside. What's our outside? Our outside is the f part. So g of x is kind of like our box. So for h prime of x, we're going to write f prime of the box of g of x. Now times what's the root of the box would be g prime of x. Okay, so I write that first. Now let's do it at 3. It wants to know is it increasing or decreasing at 3. By the way, it never told me to take the derivative. How did I know to take the derivative? Because when a question asks me, is it increasing or decreasing, it's asking me, is f prime positive or is f prime negative? If it was positive, our graph would be increasing. If it's negative, it would be decreasing, right? And the way we verify that is like greater than 0, less than 0. So h prime of 3, I always write this step. This step you don't have to write, but I really like it. It helps me to stay very organized. And so now on composition, this is where when we're plugging it in, this is where you do PEMDAS. You do have to go inside out. So when we were doing the derivatives, I was telling you go outside. Always start with the outside. Always start with the outside. Well, when you're plugging in for composition, when you're actually plugging in the value, you have to follow PEMDAS, which is start at the very inside. So what's the very inside is g of 3. So where's g of 3? Right, we said the way we read this is like this is f of 3, this is g of 3, this is f prime of 3, and this is g prime of 3. So g of 3 would be 4. So this is f prime of 4 times g prime of 3. Well, what's f prime of 4? F prime of 4 is, oops, that's of 2. F prime of 4 is 8. And g prime of 3 is 6. So 8 times 6, we end up with 54. So now that's our answer, but it didn't ask us, I can't multiply. 8 times 6 is 48. It didn't ask us for the answer. It said, is the graph h increasing or decreasing? So what we're going to say is, kind of off to the side, h prime of 3 equals 48, which is greater than 0. That's greater than 0. It's positive. So the graph of h, because it was positive, it will be increasing. Is increasing, that's the what, at x equals 3, that's the where. Okay, so the reason was because it was positive or because it was greater than 0, and then that means that it's increasing at x equals 3. Okay, next one, p of x equals g of 2x. Okay, so we're going to start off with p of x equals g of 2x. First, we need to find the derivative, p prime of x. Then, once we find p prime of x, then we plug in 1. So what's our outside here? Our outside is g, so it's g of some box. The derivative of g is always g prime, so g prime of our box, and times the derivative of the box is 2. So this will be p prime of x equals, p prime of 1 equals, now we're going to plug in 1. So g prime of 2 times 1 is 2 times 2. This gives us g prime of 2, we're on the bottom row, g prime of 2 is negative 1, times 2, and we end up with negative 2. So not too bad. And then our last one, this one's a little bit tricky, but it's not too bad. And we're going to use that shortcut that we learned about the square root. And this plus is just a separator. It's just a separator, so it's saying do them, take the derivatives one after the other. But what's the outside? The outside is the square root. So first ask what is the value of q prime of 4? So q prime of x we have to do first. So q prime of x equals, the outside is the square root. So 1 over 2 square root of, our box, everything inside stays the same. F of x plus g of x. Then times, this is where I said the parentheses is very important. Whenever you have a plus, the parentheses is very important. The derivative inside the derivative of f is f prime, and the derivative of g is g prime. This one actually looks a lot more complicated than it is. Now, if you want to move this to the numerator, you can. You don't have to, but you can. It's kind of nice. So q prime of 4 equals, I'm going to put it in the numerator, f prime of 4 plus g prime of 4 divided by 2 square root of f of 4 plus g of 4. So this gives us, we're going to be looking at this top row, right? That's where we have the x equals 4. So in this top row, we're first looking at the derivatives. So f prime of 4 plus g prime of 4 would be 8 plus negative 2 divided by 2 square root of, now f of 4 and g of 4, square root of 1 plus 7 square root of 8. This gives us 6 over 2 square root of 8, or just basically 3 over square root of 8. And that's the answer. You can box that. If you wanted to, you could also, rationalize it, times square root of 8 times square root of 8. So you could say q prime of 4 equals 3 radical 8 over 8. That's a, maybe a slightly better answer, but they'll both get full credit. And it says, what does this say about the graph when x equals 4? So what do we know about the graph? Well, if we know that q prime of 4 equals 3 square root of 8 over 8, we know, what does the derivative tell us about a graph? The derivative tells us the slope, which tells us, is our graph increasing or is it decreasing? So basically we're going to put a greater than 0 symbol. So that means that the graph of q is increasing at, that's the what it's increasing, the where is at x equals 4. Okay, so again, this was a long video, I get it, but this is probably one of the most important topics, and so if you want to go back and rewatch some of this stuff, it would probably be a really good idea.